Hello, welcome to RB CODECRUSH. Today our topic of discussion is insertions in a linked list. There are three cases of insertions. Case 1, insertion at the beginning. Case 2, insertion at any position after the given node. Case 3, insertion at the end. Let's first discuss about case 1. Case 1 deals with insertion at the beginning. Here we have a function called insertion underscore big. This function will help us to insert a node at the beginning of a linked list. Here is a parameter n, which is the value of the information field of the new node which is being created and which has to be inserted. Over here, temp is the node type of pointer which points to the new node created, and the information part of the new node is being represented by temp of info, which contains the value n, and the link part of the new node is being represented by temp of link. And now we will see the steps to insert a node at the beginning. Here is a pictorial representation of the linked list. Following changes occur if you want to insert the new node in the beginning of the linked list. New node's link part contains the same value as the roots is presently containing. Hence, the link part of new node, that is temp of link, is containing the value of root as shown pictorially. And the link which existed between root and the previous first node is cancelled or deleted. A new link appears between root and temp, that is, root contains the address of the new node or root is pointing to the new node. Hence, see, new root is containing the same address as being pointed out by temp, or root is pointing to the new node. Next case is insertion at any position after the node which the user gives us or inputs. That function is being performed by the method insert underscore any. There are two parameters, as we can see, one is key and one is n. Key is the value of the node after which the insertion has to be made, and n is the information part of the new node which has to be inserted. Here is the pictorial representation of the original linked list. Now for insertion at any position, we have to ask to the user after which node he wants to insert the new node. Let that node's information part contain key as a value. Here we have already passed key as the parameter after asking the user. Then we should traverse the nodes until key node is reached. That function is being followed by this while loop. We see that we are traversing through the linked list by this statement, that is ptr equals to ptr of link, which has already been explained in previous videos. And how long we will traverse? Until and unless we reach the node whose information part is key. So the condition is until and unless, or we can say we should enter and we should traverse the linked list while ptr of info is not equals to key. As soon as the node which is being pointed out by ptr contains an information which is equals to key, we will jump out of the loop, and hence we will do the following cases. Link part of the new node will contain the value which is the presently link part of the key node. Link between the key node and the next node is deleted. We see that temp of link, that is the new node's link part, is containing the link part of the ptr, that is the key node, and the key node will now point to the new node. PTR is presently pointing to the key node, hence the link part of PTR will now contain the address of temp, or contain the address of the new node which is pointed out by temp, or the address stored in temp pointer. Now we will move on to the third case, that is insertion at the end. The function insertion at end helps us to insert a node at the end of the linked list. Here n is a parameter which is passed, which specifies the value of the information part of the linked list. Now we should traverse a linked list until the last node is reached. We know a last node of the linked list consists of a null pointer. So in while loop, which will help us to traverse through the nodes of the linked list, the condition should be we will traverse through the linked list until the node which have a null pointer is reached. So while PTR of link, or while the node pointed out by PTR has a link field containing null, we should go on traversing the linked list. As soon as we reach the last node, that is when PTR's link part becomes equals to null, we will jump out of the while loop, and then the following will happen. The last node will now point to the new node, and the new node which becomes the present last node or the recent last node will have a null pointer in its link part. So let's see that over here you see temp of link, that is the new node's link part, will contain previously the node which was the last node, that node's link part, that is the null pointer. The new node's link part will contain the null pointer, and the previous last node's link part will now have the address of the new node which is being inserted at last, or will contain the same value as contained in temp pointer, that is the address of the new node. Here we come to end of insertions at insertions of three insertion cases. Display function has already been explained. Now let's enter into void main. Over here first we will create a linked list, then we will display the original linked list, and then we will enter into switch case, where case 1 will help the user to insert a node at the beginning. Over here you see insert beg num is the value of the info part of the new node. Case 2 will help us to insert a new node at any position. Here we have insert at any, and case 3 will help us to insert at the end, that is insert end. And lastly, after execution of the switch case, we will print the final modified linked list. Thank you for watching. If you liked my video, please like it, and to keep updated with all the videos which I will be updating or uploading, please don't forget to subscribe. Thank you for watching.